So welcome everybody, welcome to MarkLogic World and the presentation of how to plan and execute a successful cloud migration. My name is Steve Bertoldi, I'm a Solutions Director at MarkLogic, and I've been here for over 2 years, and essentially I help the customers at the infrastructure level, essentially where MarkLogic meets the metal. Oops, is it going? It's not showing the next slide on the screen. It's advancing here, but not up there.
Try now.
Okay, that's good. So some of the things we'll talk about today, essentially we'll give a high-level overview about the cloud and some of the issues that customers are starting to see with their on-systems or on-premise infrastructures. Then what we'll do is we'll go and kind of do a comparison of how things look today traditionally when you build out an infrastructure versus what it would look like on an Amazon-type platform. And then we'll go over and we'll take a look at some use cases where customers have actually used MarkLogic on the cloud to help with their mission goals and their projects. So, okay, it's up there. So essentially, what is the cloud? So I went out to the cloud to see what it would define itself as. It's auto-describing. So essentially, the cloud is utilizing compute-based resources over the internet and provides you the capabilities of elastic services and scaling services. And so you can also think of the cloud as being self-provisioning. So you define your infrastructure and your architecture, and you can build those resources out as you see fit. And so as far as features of being elastic and scale, there's two ways that we can actually scale in the cloud. You can do a vertical-based scaling, essentially make your compute resources larger, add more resources to it to compute a job, or you can scale out horizontally. So essentially you can add more nodes to your infrastructure and then can also bring them back. That's essentially the key to elastic services. You add more resources to your environment when demand increases, then you can also retract those resources back when it's no longer needed. And so since you're only building what you need and you pay for the resources that you need, it becomes a lot more efficient and a lot more cost savings to your environment. So you don't have to go out there and build a very big infrastructure to meet your high demand. It's basically you pay as you need. And essentially it can be considered infrastructure as service. You hear that term out there sometimes. So some of the cloud providers that you have out there. So you have your public clouds, which you consider multi-tenant environments. Essentially, a multi-tenant environment has other users utilizing the same hardware while you're running on that hardware. So you're sharing compute resources, network, and so forth. So we have some of the public providers out there, the Amazon Web Services, or AWS. We have Google Cloud, and then you also have Microsoft Azure out there. So those are some of the big ones. But you also have something that's called a private cloud. And a private cloud essentially is what they call a single tenant service. Essentially, you can utilize some sort of virtualized infrastructure, but it's on-house or it's decentralized such that you're the only people using that infrastructure. And so, for example, the government cloud actually uses the Amazon Web Services to set up their own private environment. So this is kind of where I tend to sit and I help customers out with. So they're starting to see a lot of issues with their infrastructure and they're starting to see problems. So some of the things that's making them drive towards more of a cloud or distributed platform is they're seeing issues at the OS level, some patches or bugs that are being required. So generally you can think of the bugs they're seeing is at the infrastructure level regarding maybe the operating system, or it could be something related to the network or possibly storage or driver related. So they find that they have to do a lot of patching out there. And patching sometimes requires downtime, and you have to schedule windows for your maintenance so that you can take your servers down. Some of the times when these patches get applied, they bring the system up and it doesn't work correctly. And so this is starting to cause issues. I was on one environment one time where the admins came in and actually patched the infrastructure, Everything went okay. They applied the patches, then they backed right or went home. A couple days later, we applied a new software release, to upgrade some of the code base, but we wanted to restart the servers to make sure everything worked okay. Well, as soon as we restarted the servers, nothing came back. Everything was broke. It was a kernel-related bug, and we just didn't have anything available. And so that caused massive amounts of downtime for your environment. So you also have issues possibly with hardware-related. Problem is with hardware-related, if you have a bug or a glitch in your infrastructure at the hardware level, it's a lot harder to troubleshoot. It's a lot harder to diagnose those particular issues. For example, we were in an environment and we're having some issues related to disk performance. So we checked everything. It was software was up to date. All the kernels were the same. Drivers were the same. But it actually occurred at the device level. So the firmware on the cards were different. It came from 3 separate batches, and that was enough to play havoc with the storage layer. And so they had to go through and level set those environments and then bring it up. But that cost a lot of downtime for the environment. Also, things they see is, so if you have an infrastructure in-house and it's virtualized, some of the problems that they're having with that is the clients or customers of the internal virtualized environments are getting their assets kind of in a fixed nature. They can't describe how much compute resources they need. They can't describe the environment. They're being dictated by the virtualization team to say, here is what you need. And sometimes those resources aren't what they need, and they can't really utilize that in their environment. So essentially, they're starting to feel the pain. Basically, when I start talking to some of the customers, the big question or big comment that comes out is they want a stable platform. They don't want to deal with a lot of the infrastructure headaches that are out there, worrying about whether or not load balancers are corrected or the network issues or storage. So they don't want to have to deal with those issues out in the environment. They want it to be stable and they want it to be running. And so what they're also finding is, as far as bare metal, the costs are not going down. They're either going up or it's costing more for them to implement an internal infrastructure to meet their needs. And so this could be to internal budget constraints, or maybe you just don't have enough resources to procure all the hardware that you would need for your environment. And so it could be, with administration, environments are getting bigger, they're getting more complex, there's more moving parts. And so it becomes a lot more complex. You need bigger teams and a lot more infrastructure to manage that complex environment. And so, sometimes what they're feeling is maybe they can't build what they need in-house for their infrastructure because it doesn't meet policies. Something internally is driving the fact that they can't utilize those resources. So they're also finding that they don't need local data centers. So I would have to admit, in my previous life, that used to be me, because I was in an environment where the resources that you needed, it was kind of like if it was free, you took it and you allocated to your project. You put something on it and you spun it up. Because if something was available or open, somebody else would come along and take it. And so some customers are deciding that internally they don't need their data centers. They don't need to have the data locally. So ask yourself, how many people have data centers out there, and have you ever walked through where all your servers are running or stored? So essentially you can decentralize that and move that to a different location. Also, essentially the best of today will be outdated soon. So it's kind of like a car. You buy a car, you drive it off the lot, it becomes, you start losing money as soon as you drive it off the lot. And it's kind of like the same with computing resources. When you go out there and allocate a server and buy a new resource, it may be the best today, but technology is changing so fast to the point where it may be outdated in a year or two. So you've got your 3-year refresh cycles. So what they're coming to is they're finally doing a realization that says, okay, here's our solution. They want to move to the cloud. And so what we'll talk about is kind of make a lot of associations of how we've been running MarkLogic on the Amazon cloud, how we've helped customers integrate into the cloud and what they've done. So essentially, we support running on Amazon Linux. We basically got everything in there, and there's no other external dependencies. You don't have to rely on any other organization or group to spin up your resources. Since it's self-service or self-provisioning, you can bring up those assets. And so they're finding that it has higher network availability. And this can stem from a bunch of different causes. Essentially, some customers are finding that components in between, load balancers or switches, are causing issues, and that's affecting the performance of their environment. And so they're finding that they're getting better resource utilization there. It's also easier to procure and administer. So, I've been through a couple of procurement cycles where we had to specify everything down to the cage nuts of the server racks in order to get the purchase order through. So when we got the equipment, we brought it in-house, we started to build it, got everything racked, we wanted to power it up. That's when we realized that the power cables that we had were the 3-prong, not the ones that would connect the lock snap into a distribution unit. So what had happened at the procurement level, they saw the line item power cable, and they said, that doesn't look like a power cable. They twisted it and changed it out. So we essentially had a problem, and that was fun getting out of there. There also, as far as availability, you have different regions out there, different regions, and they have different availability zones. And so you can utilize these availability zones as different areas for fault tolerance. You can distribute your application in those different regions inside that zone. And also, as far as backups, they're finding it's easier to back up. MarkLogic has integration into S3 fully baked into the product, so you can actually run and dump your backup to S3 and let S3 manage a lot of the history and the aging policies in that environment. So I don't know if anybody's worked a lot with tape silos, but essentially those seems to be my Achilles heel. You have your tapes that you write once and you read never. So that kind of gets away with S3. So what they're finding is, now that they're moving to the cloud, is they can deliver faster. They can build their resources, get the clusters up and running. They can deliver their projects faster. So it's saving them time as far as the infrastructure. Utilizing the scale on demand and elastic features, they now have the ability to kind of start small, grow big when they need new resources, and then retract those. So it's making it more efficient for the environment to run as well. And also they have tools that are baked into the Amazon environment. Essentially, you have your CloudWatch, you have your CloudTrail, and some other tools that you can do to monitor and maintain your servers. And also they're finding it's starting to become cheaper because now they can start recovering some in-house assets, move them to other projects. So they're actually saving some internal costs as well. So as far as traditional versus Amazon. So when you go out there and you build a server, what do? How much CPU power do you need? How many cores? How many sockets? How big do you actually need to make this work? Then you got to decide how much memory you need. Sometimes you go to build lists, they have a small, medium, and large, but the memory you need is in the larger configuration that has more CPU power and may be outside your cost range. Then you got to figure out the chassis. Am I going to deal with local storage? How much space do I have in my chassis? How many drives can I actually fit into that environment? How big can I actually make that? Then as far as your connectivity, your network, what does your infrastructure look like? Are you 1 gig, 10 gig? Are you fiber channel? How do you actually get the right cards plugged into your environment? So we've had the other issues too. When you're dealing with fiber channel, you get the LC plugs. They were different for the switches. So I've seen a lot of different headaches when it comes to the actual infrastructures. And then as far as disks, how much space do you need? Do you have onboard RAID controllers? Is the RAID good enough for what you need? Are the disks fast enough for what you need? So essentially, you have to build all those systems out to essentially get your computes for a traditional type of infrastructure. And then send a procurement and hope they don't change something out on you. So how does that translate to Amazon? So essentially, what happens is your network or your connection options, your connectivity, your CPU and your memory, the size of your particular instance, that gets translated into an instance or an EC2, Elastic Compute Cloud instance. This resource basically defines your basic compute power, how much processing capability it has, how much memory it actually has, and essentially the connectivity, whether or not you want to move up into an advanced type networking option. Next, your disk storage. So what you would normally have as far as your disks would become an Amazon Elastic Block Store volume. So essentially now you have a volume that you can attach to your instance. This provides your disk I/O capabilities. And essentially you have different types of disks. You have like a GP2 type. If you have a demand that needs a very specific or targeted I/O requirement, you can go to the provisioned I/O drives. And also you've got the magnetic drives, which are essentially the older generations. Good thing about Amazon is they essentially are adding new features all the time. And just recently, I think a couple weeks ago, they've added some more disk capabilities, so you can select the disks based upon your I/O needs. Then the AMI, or Amazon Machine Image. Essentially what this is this is your OS. This will actually bootstrap your image, or the operating system you select, onto your root volume. This is what you use to bring it up and to run your instance. And then from there, you install MarkLogic. So for the most part, it operates like you would normally in a normal server situation. You have CPU, memory, RAM, you log into the server, you can install MarkLogic by just basically installing the package. And this essentially is what the Amazon ecosystem is built around. This is how you frame and relate traditional to what actually transpires into an Amazon cloud. So how would you migrate a typical 3-node cluster? So what would you do? So say you have a system out there. It's say 3-node cluster. You have 2 CPUs, 8 cores each. Got a fixed set of RAM and 3 terabytes of local storage. So how would you go and actually build that in an Amazon type of environment? So first what you do is you go out there and you select a region. So now I'm only showing the regions here, which are US-based regions, but essentially they have regions all over the world. And what you can do is decide where you want to go. So basically in the US we have these 3 regions available. And some of the issues that you may want to consider essentially is the cost. So there may be different prices for the instances or the resources that you need. Those costs can actually change based upon the region and their availability. Something else that you can also consider as well is they have availability zones. And availability zones essentially are the different data centers in that particular region that you can utilize for fault tolerance. And so sometimes you can watch and make sure, if you have availability to spin up your resources there. So next what you do, so we picked a region. We want to go out there and spin up an Amazon machine image. So this is the actual OS or the bootstrap image. So you get a list and you get a whole bunch of different options. So essentially what we can pick here is the Amazon Linux AMI, which essentially is going to run on a hardware virtualized instance. So we're going to start and utilize that as a Linux-based platform. And essentially when we're done, that image that's out there is going to get loaded onto our boot volume. So Amazon maintains these, they maintain the images, and so periodically they go through and update these when new patches or releases go out to the field. So then you pick your EC2 instance. This is the actual compute power of your server. This basically says how much resources or how much power do you need. And you can basically pick a smaller instance if you actually have lower needs, or you can pick a bigger instance. Here again, you have quite a bit of options to decide how much computing power you actually need. And the benefit behind the cloud is essentially it's not fixed. Whatever you pick here doesn't become your final decision. You can always change that capability later. So in this case, to meet our needs based on our sample system, we would go with a C4 8X large because that would provide 32 vCPUs, 60 gig of RAM, and so enhanced networking. And the ability of enhanced networking, what that does is it separates your data traffic from your network traffic. So it gives you a little bit better network performance, a little less jitter, a little bit less latency on that environment. So then, next what you do is you define your instance details. And there's a lot of options you can do when you get here, but essentially we've picked a region, we've identified where we want this resource to go. Next what we do is we pick the availability zones. So essentially in the US East we have 4 different zones. This is the location or the data center where you actually spin up your Amazon instance. There's a lot of different features that you can also pick here. You can define whether or not you need a virtual private cloud, or if you need something, say like your subnet options, whether it's part of an auto-scaling group. There's a lot of definitions that you can actually build at this particular stage of the environment. Then the next thing it asks you is to add your storage. So you're going to need at least a root volume or a boot volume to bring up this instance. And they actually have some default recommendations when you pick it off, when you build your instances. So you can decide whether or not you want a provisioned I/O or you want a standard GP2 ones. So the one thing you need to consider is this root volume, once it's attached to the running instance, if you were to terminate that instance, that volume would go away. And so essentially, unless you protect it. So you want to be careful and maintain like a root or a boot volume and then have a separate volume for your data or for your databases. And so here, when we create a volume, we can create our root instance, and then we can go ahead and create a secondary data volume for our databases. So the security. So you can think of the security groups as your firewall. So nowadays, when you get a router, you plug it up to the internet, essentially it's going to protect you from inbound traffic. This is essentially kind of the same thing. So when you define a security group, you're defining what resources are going to be allowed accessed into your instance. So in this case, we want to do SSH so that we can log into the server, and then you can specify your ports for your query console or your admin console. And essentially, when you build these instances, these can be spanning across all of your different availability zones, so you get the same definition for your firewalling rules in the environment. And then you also have to specify the SSH key. So what Amazon does when it actually goes out there and it runs, it uses public-private keying variables so that it doesn't use password type systems or authentication. So there's a whole bunch of other cloud providers out there, and I was using one of the smaller ones, but it's set up and it used password authentication. And I thought I picked a good enough password, it was secure and everything. I let it go for 3 days, and in those 3 days it was hacked. So somebody actually brute forced that environment, got into the server, and ran it. And I thought it was, 1 day. What can 1 day do? Use shift 1 to shift 3, 4, but they got it, and they got in, and they did a job on that particular instance. They actually shut me down. So then building out the cluster. So essentially what you have when you're done, you launch it, you have one node one instance and one availability zone inside of the region. So then what you do is you repeat your process. So you go out there, and in the other different availability zones, you build an instance for your cluster. So in this case, it's going to be a 3-node cluster. You build 3 separate instances out there. Then you go and you install MarkLogic. So you can use this process like you normally would. And you can install and run and configure MarkLogic just kind of like you would on a regular standalone instance. And then the security group that we talked about, your firewalling options, this kind of spans your entire regions and your availability zones. So this is my access into the environment, and then this is how you would essentially build and start creating nodes out there in the wild. Oh, and the last thing, is Elastic Load Balancer. So you can go through and add a load balancer such that you span or you distribute your data across all the different instances. So you're not just pointing to one, you come into the Elastic Load Balancer, and then that would distribute the requests across all of them. So basically what I described was essentially the manual process or unmanaged install of MarkLogic. You do every step manually, and you do one at a time, build it all up. You can also launch it through an Amazon AMI image we have on the marketplace, and you can actually run this with a bring your own license, or you can also run it as a metered type of option. And then we also have cloud formation templates, which allows a managed feature of the cluster. Essentially, it does a lot of the background management, makes sure all the volumes are mounted, keeps track of that, and a lot of metadata for the system. So let's take a look at some use cases that are out there. So the first one, this was a system. They weren't actually running on Amazon, but we migrated a test environment to the Amazon cloud. So they were building a larger system, and MarkLogic was coming in as a transformation hub in a smaller component of it, but they had to go through and make sure that they met their SLAs. They had very well-defined SLAs in the environment. They needed to make sure that they could test it. Problem was, the hardware was already in procurement. So it was already sent off to be bought, and now they're testing to make sure that the hardware they bought meets the needs. It's kind of backwards, but that's what was happening. So I get a call and says, can you get on a plane? And essentially what was happening is they were testing using internal virtualized environments. Problem is, the server they needed was this big. The resources they used were this big. And the numbers, the metrics that they're recording on their tests weren't matching up, and they started to get a little panicked. So there was a little bit of worry going on. So essentially the way this worked was a transformation hub. Data would come in, they would load the data, mash it around, and then move it on to a different stage down in the pipeline. And it was a large amount of records, a large number of pieces of documents going in, so they had to meet those targeted SLAs. Also, what was happening is just bad performance on the virtualized environment. Now they went internally, said we need resources. They carved them up machines on the virtualized platform, and it just wasn't cutting it for them, so they couldn't actually use it. So what did we end up doing? So we went out to Amazon, and we started to spin this up. Because right now it's the middle of the week. I had a week on site, and I couldn't actually look at their environment. I couldn't get in and see what was wrong. The virtualization team says there's nothing wrong. And so we had that battle that was going back and forth, so we decided to bail and move out here. So what we ended up doing was we set up a virtual private cloud. Because I wasn't sure about what the environment was doing or what they were needing in their environment, I didn't want to open outside ports to the world. So I wanted to keep it all contained, and then users would actually connect through a VPN. So we set up a VPN system, gave them all accounts, and they used software-based VPN on their laptop. They would spin it up, they would connect, and now they're in this internal network. They can see all the resources, they can define everything they need. They don't have to change the firewall rules on the fly. Next, we went out there and built 4 machines. And so we went through and found the instance type that matched what they were using on their infrastructure. So essentially, we had 4 nodes, which were the processing nodes, and then we had a 5th one, which was the data logging system. And once we got everything lined up and matched, we went ahead and loaded the data. So when we loaded the data, basically everything was in the cloud, this own private testing environment. They found that they were able to meet their SLAs. So there's a big sigh of relief that says, okay, the hardware was matching what they were needing and everything was okay. But there was one other issue that we found, and it was the transformation job. It was an external job that would go in, do some work, and also transform, but this wasn't meeting the needs. Can anybody guess what was the issue? No, actually, this was pretty good. Well, I did make a mistake on the disk, so we'll cover that. We won't talk about that too much.
Memory.
No, not so much memory. The memory worked out because of the loading one. We weren't meeting the number. We weren't getting enough documents transformed. So we were only pointing to one of the nodes. So we were using only 25% of the entire cluster to process the data. And we were talking about it, getting closer to the end of the week, and I said, we can load balance this stuff out, and they were kind of concerned because that would take time, and we were having a discussion. By the time the discussion was over, I had already plugged in the ELB, the load balancer, into the environment. And so all they had to do was point to the load balance instance, and now they've actually met their numbers. So what's nice about this is these resources are available to you out in the cloud. You need a load balancer, you can define it, you can plug it in, it's ready, and it's ready for you to go. So this was actually all done in about 2 days. So the next use case. So this one is a little bit different. So kind of same type of hub type of operation. But what would happen here is they would use it as a lookup service. So they didn't need a lot of power for the queries. They were pretty simple, but they needed to transform and process a lot of data every night. And so what was happening here is they're already on the cloud, but they weren't meeting their SLAs. So here again, we're looking at what we can do to fix it. So this was kind of what their environment looked like. They had a 3-node cluster out there. They had their application hitting a load balancer. And this part was fun. There wasn't any issues with that. The problem is from their legacy data source, when these records were coming in, they were also hitting the cluster as well. So they kind of sized it for like a medium-sized cluster, and they're still thinking in terms of a traditional standalone server. I must buy this. I must instantiate this type of instance. So you could say they weren't thinking three-dimensionally. So how did we fix this? So we went out there and scaled down the primary a little bit because they didn't need a medium size. They could do a lot better with the smaller instance. Could save them some money. So we went down with 4 virtual CPUs for each one of these nodes. Then what we did is we created a secondary cluster. So in this case, this was also a small cluster, and this would receive feeds throughout the day, these new records that were coming in that they had to bring on for the following day. So what we did is we separated the transform job, or the load job, from the primary cluster, which was our search service, and then we moved that into the secondary one. So when it came time to transform, at the end of the day, they needed to meet specific SLAs. So what we ended up doing is we stopped the job, so now there's no more new records coming into the system. And then we scaled up. So we took this one, and we increased these virtual CPUs on it up to 32. Because this was a very high CPU-intensive job, we wanted to make sure that we got everything done and we processed it as fast as we could. So then the transform job kicked in. It ran on each one of the nodes, and this actually helped them with their environment. They could actually meet their SLAs at this point. And then for scale down and switch, once we were done, it took just a little over an hour for this to run through. We scaled the system back down, so we made it to a small, so now it looked like the original system. And then when we're ready to switch, we pointed the definitions to the new instance. So essentially, those new jobs were done, the transforms were taking place, we flipped it immediately, and it was brought back online. Then, to finish it off, you point the loader to the other instance. So in this case, you basically created a kind of like an A/B or an alternate type environment to handle your processing. And the last case, this one's a little bit more complicated out there. So it was a cluster system they had out on Amazon, and they wanted to be able to meet the loads of traffic throughout the day. They knew that at certain times of the day they had more requests, more heavier CPU requirements. Then on weekends, on evenings, they didn't need all that processing capability out there. So they wanted to be able to add resources in and also pull them back when there was no demand. So this was how it actually looked like. This was the initial setup. So they had their master cluster, and this would receive all the documents, all the incoming data to the environment. And they would do some markup, some processing of documents at this cluster, and this was kind of like the static one. This one didn't change. But when it came time to search, what they did is they created a separate single node instance out there in Amazon. And so what would happen is create the snapshot of your primary cluster, attach them to the foreign cluster, and then define replication. So in this case, this instance over here, now there are a few more of them, but I'm just going to show one. This was used for the searching level. So when users needed to come in and do more activity, they would actually hit this particular side of the infrastructure. And so they decided to use scheduled auto-scaling, essentially to say at certain times, increase the resources, and when the load is over, basically bring those resources back. So here's how they scaled up. So essentially using the combination of like OS provisioning type tools and cloud formation, they went through, and the first step was to go ahead and snapshot the master cluster. So now, whenever that snapshot is taken, it's an actual image of your primary cluster. And then what they would do is spin up another Amazon EC2 instance. So now I've got the instance out there that has MarkLogic loaded. What it would do is then attach the volumes to that instance. So now what I have is another standalone instance, but I want to make sure that the data is up to date. I want to make sure that everything that goes into the master makes its ways to both clusters, because we want to make sure that the documents are consistent across all the new nodes. So then you go out there and associate that foreign cluster with the master. So this would be the first part for database replication. And then after the database replication was set up, the replicas were attached so that we could bring the data from the master cluster over. And so this is how they would scale up that environment when loads were increased. Essentially, you would hit a load balancer, and then it would direct the traffic to each one of those instances. Then the inverse, essentially, you want to scale down. You want to pull back these resources. So first thing that you want to do is you want to go through and disable replication. You want to detach this resource from the master so now it goes back to its standalone type of configuration. Then once you do that, you're going to go through and clean up the instance. So you want to stop it, which will get rid of your in-memory resources, so you're no longer incurring a fee or utilization for that. And then you also clean up the disks. So basically, you're recovering your resources when you no longer need them. So sorry that went kind of quick, but that's essentially the more complex use case. And they would go through and expand a lot more nodes as it was needed. So in wrapping up, essentially as a takeaway, it works. Customers are utilizing this in their environments. It's helping them build faster. You know, they're getting quicker returns. They're able to test, do things that they wouldn't able to do in-house. And so essentially with the capabilities of elastic and scale-out resources, it's a lot more flexible. Normally with a traditional infrastructure, you have to realize a capital cost in order to gain those resources so that you can actually scale. With Amazon, you don't, or like a cloud-based environment, you don't have to do that. And so the key is it's always changing. They're always bringing new enhancements on there. They're always bringing in new features and new capabilities to help out with building your infrastructure. And also, it's getting cheaper. You know, more cloud providers we have out there, the more, the cheaper the cost is over going to be. So, does anybody have any questions?
Do you have any use cases for any of your customers doing Docker containers for scaling using Docker?
Okay, so his question was, do we have any customers using Docker-related containers for scaling? I'm not exactly sure about that, but I'll see if I can find anything out. And if you want to find me later on, then track me down and I'll get some information for you.
Hi, thanks for the talk. When you said there were also OS provisioning tools, do you mean like Chef, Puppet scripts?
Yeah, so exactly. For that last model, essentially the CloudFormation would launch an instance template or a scaling, you'd go into a scaling group, you would have a launch configuration that would kick off. And then internally, you can actually bake your own AMIs with some tools, and they used Chef to actually go through and do some of the OS automations.
Yeah, for the system setup, sometimes we make a system change like swappiness and page, build page.
Mm-hmm.
Will Amazon support those things because we made a change they don't support anymore?
So the question was do we support?
Optimization, swappiness change?
Yeah, so essentially it's like for the syscontrol conf files, the parameters that you would use to control how the system swaps in pages. So on the hardware virtualized instances, you can make those same changes that are out there. So it will accept those changes. And some of those parameters are dynamic, which means you can actually change it without a reboot.
Any other questions? Okay. Thank you very much, Steve, for your time today.
Thanks.